I know sometimes when people hear about the game design methodology, sometimes they assume things like, oh, we can't wait to see your first-person shooter game. But the game design methodology is not based on that. It's not, it could be, I mean, that's a few iterations away, but the game design methodology is about building that digital version of a physical prototype of a game. It's about the logic that makes the game work. It's not about becoming a game programmer. It's about taking what we know, what you know about the course concepts, and applying them to a game that you create from scratch.
How do you help more students succeed in engineering? These are often difficult subjects. They're difficult and many times abstract. So how do you take something that's challenging and abstract and get students to be engaged in it in a deeper way and help more students succeed in that? So this is where National University is using the idea of not game-based learning, but game design as a way of engaging students in the subject matter. And they're finding that students will, because they want their game to represent the real phenomenon that they're studying, they'll go to great lengths to make sure they understand it, great lengths to make sure they know how to model it, great lengths to find creative ways to express it in their games. And then they inflict these games on their friends, and it's great fun.
And I call it sustainability, the 3 E's. The one time I played the game that I made, I lost. So, but it was still a lot of fun. It was definitely fun.
The idea is that each of those areas where he's talking about questions are the principles of conservation that we talk about in the class. And the questions that you saw there are examples that we use in the class to teach these concepts. And there's a lot of math involved too. There's quite a bit of energy math and conservation equations and stuff like that. But here the idea is that if you're just playing with this could be a very, I think you had said that this could be good for schools the way it is laid out. For you're talking about high school children, this would be a wonderful way to teach them all about sustainability and all the different E's.
Students want to be the creators of their education. They want to build the relationships between concepts in the courses, and this gives them that opportunity.
Students show and develop new skills that usually I don't get from my students. In this type of group assignment, there are some guys who are more math oriented and they really can do the Excel things, the formulas, and they can teach the others how to do it. There are other students that appear to have graphics skills, and then those are the guys who put the pictures and those things. And there are other guys who have this theoretical thing. I mean, those are the, let's say, the more academic oriented students. Those are the ones who set the rules of the game. And then when they are collaborating, they mix each other, and everyone more or less feels more satisfied.
This is the game interface that we came up with. Just an idea here. I might want to emphasize that this is a work in progress.
Core to the design of the Catalyst Initiative, we're looking at what we call STEM education in the U.S., science, technology, engineering, and math. Well, in the 21st century, these subjects, S, T, E, and M, there is not a period between them in real life. As a STEM practitioner, you can talk to anyone in the high-tech world. S, T, E, and M are very interconnected. And students don't need to see those connections. They don't necessarily have to learn them as everything's interdisciplinary, but they sure had better see the connection between the math and the science.
When we, as a university, National University, when we outreach to K through 12, as well as the juvenile core system schools, having the ability to put technology in the hands of these young students, hopefully who are going on to college, that's what we're trying to inspire them to think about, that has made all the difference.
Yeah, I saw, I would say maybe 4 or 5 of the students that are really never engaged. They're just not interested in education at all. All of them were lit up. They're all engaged, they're all smiling, and it's just wonderful to see that.
Well, I want to graduate and then planning on going in the military. Like, then after I get out, probably like getting into some art school or something like that.
We have the kids come in, they start off playing games, whether it's on the Xbox, the PlayStation, the Wii, and it gets them engaged, it gets them thinking about, oh, this is all cool, this is everything, and they don't quite yet understand what we're doing, but they're playing games. They would get them excited, and we have James come in, he talks about the different career paths that you can have.
Well, it's called Catalyst for a reason. It's designed to be a little bit of that little ingredient that allows a reaction to take off. And if we can plant that catalyst in a group of innovative educators and they can demonstrate what the way forward will look like, then the long-term vision, the long-term scale is to bring other partners on board, to bring other funders on board, and help the best ideas grow.
I tell a story about the first time that we included HP tablets into our outreach. We break out the tablet PCs, we hand them out to the students. My partners Romeo and Dax begin to teach them how to do concept art for video games on the tablet PC. So it's tactile, they're actually inking. We go through the whole thing, and for the first time, one of the young ladies in the classroom walks up to us and says, "Okay, how do I go to college?"